Okay guys, we are now graphing linear equations. We've been doing this for a while, but we're going to continue doing this, and hopefully the more you see it, the more you're exposed to it, the easier this will become. Okay, so we want to sketch the graph of 2x plus 3y equals 9. So, there's several ways to do this. I'm going to show you one way to do this. If you solve for y, that means get y by itself, then what you're finding is you're finding the slope and you're finding the y-intercept. And those are really two pieces of information that you need to graph a line. So let's do that. So I've got 2x plus 3y equals 9. In order to get y by itself, I always move the x term. So I have to do the opposite of what's going on with the x. That creates 0, so it goes away. So I'm left with 3y is equal to, in slope-intercept form, we have the x term come first. Those are not like terms, so don't try to combine them. Now, in order to get the y by itself, that 3 is multiplying it, so you have to divide every single term by 3. So I've got y is equal to negative 2/3 x plus 3. That means that my slope is negative 2/3. My y-intercept, or my b, is at 0, 3. Start here. I'm going to start at 0, 3. So on the y-axis, which is my vertical axis, I'm going to go up to 3. 1, 2, 3. From this dot, I do my slope. My negative 2/3, that means down 2, right 3, down 2, right 3. Or it could mean up 2, left 3. Connect your dots, draw your arrows on the end, and don't forget that the math department would really like it if you did this. So would I, so go ahead and do that. And you're done. You've just graphed the equation of that line. That is in standard form. You turned it into slope-intercept form just to help yourself graph it. Okay, so this page says that you can actually graph a line using the intercepts. So in order to find the x-coordinate of the intercept, you substitute 0 for y. In order to find the y-coordinate, you substitute 0 for x. I'm sorry, the y-intercept, you substitute 0 for x. So let's take a look at what that means. Okay, so in this problem right here, I've got 5y minus 2x equals 10. So if I am ever graphing something just by finding the intercepts, I always do this first. I always write let x equal 0, let y equal 0. And then I solve this thing twice. So if I let x equal 0, I've got 5y minus 2 times 0 equals 10. This goes away, so I'm left with 5y equals 10. Divide by 5. Y is equal to 2. So now I have an ordered pair. My x is 0, my y is 2, so I have a dot at 0, 2. That is my y-intercept. When x is 0 and y is a number, you have found your y-intercept. Alright, so now I'm going to let y equal 0. So I've got 5 times 0 minus 2x equals 10. This goes away. I'm left with negative 2x equals 10. Divide by negative 2. X is equal to negative 5. So now I have x is negative 5, y is 0, so I have an ordered pair at negative 5, 0. This is my x-intercept. It really only takes 2 points to create a line, so I'm going to graph both of these. 0, 2 is right there. There's my y-intercept. Here is my x-intercept. Connect your dots. I did my best to go through that dot. So connect your dots, draw your arrows, write your equation of the line. Always go back to the original version of it and write that above the line. Okay, I'd like to point out that they actually found a third point here. And that's okay. You're welcome to find a third point too, just to make sure that it does lie on that line. Remember, 16/5 is the same thing as 3 1/5. So really what I'd be looking for is 3 and 3 1/5. So I'd go over here to 1, 2, 3, 1, 2, 3, and slightly above. So yes, that point does lie on the line. And you really just do that third point just to check your work and make sure that you have everything lined up in a straight line. Okay, so to graph a line, you really only need 2 points. It doesn't matter if you have the intercepts. You could have any points that lie on the line. And if you remember, we've talked about any line has an infinite number of points. So all you got to do is find 2 of them. Now, we do recommend that you use 3. And the reason why we recommend that is because sometimes we mess up in math. And you know that if you don't get these 3 points to line up in a line, then you have messed up somewhere and you should check your work again. So that's why we always recommend that you use 3. But just to let you know, you can use any 3 points that lie on the line to graph it. Okay, so look at this one. They're just showing us that it is possible to find the graph of a line with any 3 points at all, okay? And in fact, we're just finding 2 here, but check this out. So it says here, find y when x is 4. So I'm going to let x be 4, and I'm going to see what I get out for y. So I've got 3 times 4 plus 2y equals 8. 3 times 4 is 12. Now I'm going to subtract 12 because I want to solve for y. I've got 2y is equal to negative 4. Divide by 2. So x is negative 2. I'm sorry, that's a y. Let's erase that. There we go. So y is negative 2. There we go. That's better. Okay, so now we're going to find x when y is 1. So we're going to let y be a number this time. So I'm going to let 3x plus 2 times 1 equal 8. 3x plus 2 equals 8. Subtract 2 from both sides. I get 3x is equal to 6. Divide by 3, so x is 2. So there we go. Now we have 2. 2 points anyway, so 4, negative 2. 2, 3, 4, 1, 2. There we go, right there. 2, 1. 1, 2, 1. Now, the thing is, I want to know if these 2 points, if maybe I made a mistake in my math. So I'm going to pick just one other random point. And I'm going to let, I don't know, let's find the y-intercept. So let's use a different color and let's let x equal 0 and see what happens. So I'm going to do it up here. So I've got 3 times 0 plus 2y equals 8. So I've got 0 plus 2y equals 8, so that really goes away. Divide by 2, so y is equal to 4. So 0, 4, so 1, 2, 3, 4. Does it look like those points line up? You can always count the slope in between the points and make sure it's the same. 1, 2, 3, left 2. 1, 2, 3, left 2. Yep, that's good. Alright, so there's my line, and then write the equation next to it. Alright, we just graphed it. Okay, so if I compare linear equations in 1 and 2 variables, so if you'll remember correctly, whenever you have just an x in the equation, then this is a vertical line. It has a slope that is undefined. When you only have y in the equation, you have a horizontal line, and it has a slope that is 0. But when you have a y and an x in the equation, then you have some line that has a slope not equal to 0 or undefined. Okay, so anytime you have only one variable, you have a special case of vertical or horizontal. If you have two variables, then your line will have some sort of slope to it, and it won't be 0, it won't be undefined. So let's take a look at these two and let's talk about them. So describe the solutions of the equation y equals x plus 1 in two variables. Well, if I have this, let's see here, if I put in 0, 0 plus 1 is 1. If I put in 1, I'd get out 2. If I put in 2, I'd get out 3. If I put in 3, I'd get out 4. So I know that whenever I graph this, I would have something that looked like this. Okay, so let's look at number 2. Describe the solutions of the equations 3 equals x plus 1. Notice how I only have an x in this equation. So I'm going to subtract 1 from both sides and I get that x is equal to 2. That is a vertical line. Right here, x is 2. So the solutions to that, no matter what, because there's nowhere to put anything for y, you could have any number you want there, you're only going to have 2 in the x position. So this one is a vertical line. This one has a slope of 1. Alright guys, that's it. I hope this helps. Have a good day.